Hi, my name is Valery Kravchuk. I work for MariaDB Corporation as a principal support engineer, and today I'm going to present you a few details about new MariaDB 10.5 features related to troubleshooting. I'm presenting this from a small town of Vyshgorod, near the capital of Ukraine, Kyiv. I work in MariaDB and MySQL support for more than 15 years already. And in recent years, I'm also a community person, a public person with a blog, a lot of MySQL and MariaDB details published on my Facebook page, with a Twitter account devoted mostly to MySQL bugs. Before that, I was a trainer and consultant working mostly with Oracle databases, so it gives me some Oracle background that is related to today's talk, and I've worked out a habit of creating a simple and clear presentations that can be also used as a reference. So whenever you see an underlined item in my presentation, you can click on it and get a lot of useful and way more interesting information than in presentation itself. I think so. So it's a reference. I should say that I work as an independent consultant. I'm not a marketing person for MariaDB Corporation, so all the views and ideas in my presentations and writings in public are my own, and I do not speak for MariaDB Corporation in any way. This session is devoted to the new 10.5 features in three main areas. First of all, finally, we got more or less incorporated all the instruments and ideas from MySQL 5.7 performance schema. So performance schema became way more useful. Then we also added some tables to the information schema to make the internal workings of the yet another killer MariaDB feature, namely thread pool, more visible to the end users and DBAs. And there was also a small improvement in the analyze statement that allows to present the way query was executed with details about rows and time spent. So a bit more details are included now. Most important is surely the performance schema improvements that all our users are waiting for several major releases already. To understand how large was this change, we can compare the number of tables in performance schema. That was 52 in the previous release, comparing to 87 in MySQL 5.7 and 80 in MariaDB 10.5. Few tables are still missing, and these tables are mostly related to the group replication feature that we do not have in MariaDB. If we speak about the related variables, we are now having the same number, 42 variables that allows us to set something related to performance schema. If you ever read the new features of MariaDB 10.5 knowledge base page, you will probably noted a section what's new in performance schema that refers to the tasks that were implemented by dev numbers. You can surely click on each and every of these numbers to see what was implemented, but the details there in public tasks are quite limited, so it's not really that much useful. So we will just use it as a reference of what additional details are now instrumented. So we have additional memory instrumentation, metadata logs instrumentation, prepared statement instrumentation. We instrumented status variables at global and server levels, added some instrumentation for storage procedures, added some instruments for SX shared exclusive logs, locking primitive widely used in InnoDB, some instrumentations for transactions, and the last but not the least, for me specifically, is the way to get the values of user variables in user sessions. Previously, one had to apply tricks like reading the internal structures with GDB that I personally had to do. So I really appreciate this addition. A couple of things are not clearly documented, and of them we have several replication-related tables in the performance schema. It's work in progress. It's not yet completed for 10.5. And one important thing for all of you to note is, unlike previously in 10.5 and in MySQL 5.7 and newer versions, we have one important change in the way performance schema works. Previously, it had allocated the memory at startup. So whenever memory grows at runtime, you could be sure that performance schema is not a part of this leak or supposed leak, or whatever is it. It's no longer the case. In MariaDB 10.5, some memory to the performance schema instruments is allocated dynamically depending on the load, number of connections, number of tables opened, and things like that. So it's important detail that I wanted to highlight. This highlight actually goes to one of my blog posts where I studied this and presented. So to summarize, instruments, performance schema still controlled in the same way as before. If you want to instrument something, you have to enable specific instruments, and you do that through the performance schema setup instruments table. So we have additionally, just for memory instrumentation, added 270 instruments starting with memory. That's cool. They cannot be timed, but they should be enabled. Some are enabled, some are not enabled. Important thing about the instruments is, and it's presented in my blog post, that some of these instruments are not enabled at startup. And even though they are dynamic, unfortunately, some of them can be enabled only at startup. Think about the InnoDB thread pool. So the huge memory allocation for a thread pool. So to see it in the performance schema tables, you have to add in your CNF file the appropriate enablement. So all that you can see, it's just a small detail. It's common for MySQL and MariaDB as well. So besides instrument, these additional memory allocations are represented in 5 additional tables that were added. You can see the structure in the MariaDB knowledge base, and we will study one of the tables. Memory summary global by event name. So for each event representing specific place where the memory is allocated, there are a lot of details presented. Additionally, in other 4 tables, we have this split or detailed for example, for a specific user and host in memory summary by account by event name. So account is represented by a pair of user host as it's normal in MySQL and MariaDB. You have a summary by host, so different users from the same client host may be checked for the memory usage. And you have a summary table per thread. So you can find out which thread, which user thread uses most of the memory or allocated a lot of memory in specific area. To find out the real MySQL connection ID that you are interested in, you have to join this to performance schema threads table, and you have to join with thread ID column, and there you can find out process ID for the related thread. So that's all interesting. These are additional fields. Let's check on the main fields. Main fields for each memory event are event name, surely, number of allocations, number of allocations, number of attempts to free the allocated memory of this kind, total number of bytes allocated, total number of bytes freed, and current number of bytes used. So the first 2 is related to the later of those highlighted. So total allocated minus bytes free is current number of bytes used. You have also high and low allocations historically, so you can see what was the largest allocation for this specific event. I also suggest you, really suggest you to check MySQL 5.7 manual, which is very detailed and have a lot of examples of this stuff. We can easily check memory allocations. It's a typical query, for example, find out which memory event, which kind of memory was allocated most often, for example. So top with limit 1, we have a top memory allocator. Where I've got this information from? Actually, it's a test that we should probably check. So I've set up for several examples in this talk. I've set up a simple sysbench test. It's OLTP read-only that does some point selects, range selects, and whatever. So when it runs, it generates some load. And then in another terminal, I can check the result of this load. So if I look for memory, I can see, just sorry about that, I should add performance schema here. And we can see that top allocation, that's what was in my presentation, was actually for quick range select, so somewhere in the optimizer. You can see that current number of bytes used is really small, but total number of allocations was quite high because we have a high concurrency. Another next one in top allocations is some memory pool inside InnoDB. And I would like to highlight these interesting numbers here. You are not supposed to see negative numbers here, but you do. It's a known and open bugs in MySQL as well. So along with the feature that we ported, we inherited some bugs. Don't be surprised. If you're interested in the chat, I will show you these bug numbers so you can monitor them for further solutions. To summarize, the internals of the memory instrumentation are different. There is a discussion here in my blog with a key developer, Vladislav Weintraub of MariaDB Corporation, who explained what is the internal difference. Supposedly, our instrumentation of memory is more efficient. I highlight once again the important detail that memory now may be allocated dynamically. So performance schema is a source of kind of memory leaks. And surely we can see a lot of other details. I've demonstrated a bit different queries, so feel free to check different queries. Follow my blog post, I explain all this stuff there. Let's move on. Another additional instrumentation is devoted to metadata logs. We have a metadata log info plugin historically in MariaDB for quite some time. But in some cases, it's useful to be able to see the metadata logs info in the way performance schema presents it. It's easier, it's always there, and it's easier to join if it's all in the same performance schema if possible. So there is only one table, metadata logs, single instrument like metadata, nothing fancy. You will see metadata logs for sure whenever anything runs. So just by selecting from the metadata logs. What about now? Now we have a lot of metadata logs, and surely it's tables from sysbench test. So sorry about that. It's all written on the slide, but I'm too lazy to just copy paste. So important thing here is also that you, if you want to find out which user connection had set the metadata log, you have to join to performance schema threads thread ID table and check process list ID there. So I will not go into the details of what kinds of metadata logs exist. It's nothing new was really added in 10.5 in this regard. Now, speaking about the performance schema, yet another area that we lack before for the visibility is prepared statements. Sysbench uses prepared statements. So now we can actually enable instrumentation, there are several instruments for both server-side prepared statements, like prepare and execute, and for API prepared statements, so-called binary protocol prepared statements, which are MySQL STMT, some C functions in C or other connectors. So there is a single table for prepared statements. So if we check it, we can select count. Surely you will see only active prepared statements there. So now you see 0 once again. That's because the test had completed. As soon as it starts back, we can see that Sysbench does use prepared statements for its activity. So here for this session, I enabled and set allowed to measure time for all kinds of prepared statements. There is one addition in MariaDB related to the feature that just does not exist in MySQL. It's execute immediate. So when you prepare a statement in place from the string in one step and execute it. So that's additional instrument comparing to MySQL. So we see it works really. We can see what's there indeed if we just do this limit one while the test works. We can see there is some prepared statement. It's not even commit as in my case that I captured for the slides, but it's a real select of a kind that Sysbench often uses. So it's cool. Now status variables. It's the same that you can see with show global status, but when they are presented in the relational table, you can apply all power of SQL at the server side, not in your applications. Several tables were added, 8 in total. 3 of them are more or less unique to MariaDB. So we have just performance schema global status with current global status. We have performance schema session status for current request in session. But what's more interesting, we also have access to status variables for specific thread. It's not unique, surely, but also for the account, for the user, and for the host. So we can like summarize how many read operations all users from specific hosts had executed. It's really cool. Yet another thing is storage procedures instrumentation. I suggest you to read and follow this work log from MySQL, the most detailed description. I cannot find anything similar in MariaDB knowledge base. So if you are not up to reading the code and all the tests and everything for specifications, just read the work log to get the general idea. So previously, there was only kind of object type that was instrumented. It's a table. View surely is also considered a table. With this change in 10.5, we added 4 more things instrumented, specifically functions, procedures, triggers, and events. Storage procedures. All of them are by default, you have to do nothing, are enabled and timed in all databases but system databases, MySQL, information schema, and performance schema itself. So you have to do nothing, you can just check everything. The statement to check is a bit non-obvious for somebody. For the events, you have to check statement scheduler instrument. All the other instruments, and there are many, are called statement SP, storage procedure. And you will not find your familiar commands, typical storage procedure commands inside. They're kind of abbreviated. So there are jumps, return, set, and everything, but not literal statements that you may be used to. Still, you can set all this instrumented, and then you can see how it works. Additionally, it's all timed, it's all included in all the summary tables. There is one additional table created, event statement summary by program. So for specific storage program call, we summarize all the times and number of calls for the specific events. As for a quick demo, I have here, that's why I had test, a small procedure called P1, very creative as usual. Sorry, I missed D. So that's it. It's a typical MariaDB storage procedure. It was created in Oracle mode, and you can see that we use, for example, implicit cursor and cursor for loop. It's cool stuff. So the procedure does nothing fancy really. You can just call it without arguments. It selects usernames from MySQL user table. But what's more important, that you can check the table now, event statement summary by program. So you can see, sorry, we have better to switch to performance schema. Yes, statement summary by program. So if we can check this, we can see that, for example, the procedure P1 was called 3 times, and here how much time in picoseconds was spent executing statements inside. It's nothing special. Call was instrumented previously, but now you can split it into the individual statements and get all the details. This is really a cool part that's yet to be presented in details. Another thing, so-called shared exclusive locks. These locks are used by the InnoDB implementation a lot, and we now have them instrumented. It's internal serialization primitive. It's interesting to check the instruments with name like SX lock actually. Set up instruments where name like %. You will see some famous stuff here. So these are locks, internal InnoDB locks that every DBA and many developers should know, like dict operation lock for dictionary, dict table stats for InnoDB persistent statistics, transaction purge ledge, BTR search ledge. All that stuff is quite important, and you often see it. Now it can be instrumented in detail, so you can see how much time in summary was spent on this stuff. So as for transactions, it's quite simple. There are 3 tables summarizing transactions. Current history, history long, related consumers should be explicitly enabled as well. What's more interesting is that now in MariaDB 10.5 we have 4 levels of hierarchy of events. So we have transactions consisting of statements. Statements are executed in stages, and each stage may have to wait for several events or specific waits. I will not show the demo now because I'm a bit out of time. I hope to present a link to the blog post while this session is going live in comments. The last but not the least is user variables. So there is a single table, user variables by thread, and you can see which user variables are defined in each thread and what is the value. It's easy. Let's just define a user variable and then select from user by thread. That's it. We have a that's from some of my previous tests. We have a variable named a with the value 1. Now go find out this without GDB from any previous version of MariaDB. It's really impossible. So that's the example. It's quite simple. Now, speaking about the replication instrumentation. Replication was also additionally instrumented. Related tables are are just 4 out of 8, as far as I remember, in MySQL. They are only partially documented in the knowledge base. There is still work in progress because one of the important tables is missing. We have replication applier configuration, applier status, but we do not have a coordinator status. And if we speak about parallel replication, we have a replication coordinator thread and replication applier threads, maybe more than one. So all this should be documented and implemented one day. Probably it will be in 10.6. So speaking about the thread pool, for thread pool, we have 3 tables added. As far as I remember, in the information schema. So here we have to go information schema. And here desk, sorry about that, thread pool. QEs. Okay, I made a typo again. So that's it. We have thread pool QEs, we have thread pool groups. Moreover, well, I had not personally used it in real life yet, so I'm a bit slow trying to understand and explain at the same time what is it about. Another important addition is that there are also 2 additional variables. It's not clearly documented in the what's new. So now you have a way to create a dedicated listener thread per group and not be blocked by long-running queries. And to control the content of these 2 additional tables, there is also additional variable thread pool exec stats. When it's set, you have more precise information here. So the only useful reading that I was able to find out so far about this is the following commit that I linked here, so go for it. Finally, the analyze statement. I will not go into much details here. Thing is, now we have 2 measures of time spent. The table access time is reported separately, comparing to the time spent on checking the rows from the table, processing where clause for the table. So now time sums up nicely in the analyze statement for sub-stages, let's put it that way. To summarize, MariaDB added a lot of useful features for troubleshooting, mostly in the area of performance schema. For those using thread pool, and it should be all of us with many connections, there are also a lot of additional details visible in the information schema. Unfortunately, not all this stuff is documented, so I'm going to do it in my blog posts, and I hope it will be done in knowledge base as well. So it's work in progress, even though 2 minor releases of MariaDB 10.5 already happened. Thank you very much for attention. We are a bit out of time. My last word, as usual in all my presentations, is the following. Please report any issues, documentations, code bugs, your problems that you suspect may be a result of a bug in our public bugs database, jira-mariadb.org. Do as my wife did when she noted a nice bug. Just make a photo, make a snapshot of data, present it, and help us to make MariaDB better together.